this reaction? So this is, you can form an anhydride with 2 carboxylic acids using P2O5. Right?
Okay.
Do you remember Fischer esterification?
I remember learning it.
So we can use Fischer esterification. You can open your notes, we can look at it really fast. That's where you drop in an alcohol. You start off with a carboxylic acid, you drop in an alcohol, an acid. Okay, so all Fischer esterification is starting off with the carboxylic acid here. You drop in an alcohol, right?
Mm-hmm.
And then you have some acid. And it should make sense that this is the nucleophile, right? And it's just going to substitute this guy, and that's the nucleophile there. Cool.
Mm-hmm.
Now, this is not going to happen. The reason why it's not going to happen is when you drop in the amine here, it's just going to deprotonate this. It won't even react at the center. So when we want to do a substitution reaction, the nucleophile has to go here, right? But because the amine is basic, it's not gonna go here, but it's instead going to deprotonate this guy, and the reaction is not really going to happen the way we want it, so it's not going to happen. The professor might have talked about this. Amide, amines. Second. Okay, just okay. Okay. Does this make sense so far?
Yeah.
Right. So I want to make this table complete because I think it will really help you out. Then we can look at some synthesis questions and figure out some more stuff. Okay, let's see here. You've already got 2 there. So the nitriles, they're a little bit of an exception. They're kind of to themselves a little bit, or to itself. So now, if we start from here, of course we can get. Yeah, I know this is going to be a little bit hard to do. We got to make it work right. What do you think we're going to do to get this to the carboxylic acid?
Yeah, which one?
To the ester. So all the carboxylic acid derivatives, they can all be hydrolyzed back into the carboxylic acid. So anyone you start off with, you can always convert it back to a carboxylic acid. Then you can always convert it to the acid chloride and then get everything else downstream by adding whatever the nucleophile is. So what do you think we would do to get here? What do you think we would have to drop in?
H3, of course.
Perfect. Heat. Right. Then we can actually produce this again using trans-esterification. So we can actually produce from starting off with one ester. We can produce the same ester So starting off with an ester, we can produce the same ester using transesterification.
Produce like a different ester also, or just the same?
Different ester. So what do you think we would have to drop in here to get this ester here?
The R2 group?
That's right. Right, and it's usually done in, it can be done in both conditions, acidic or basic condition. These reactions will be occurring in acidic or basic condition. Alright, so this is where Fischer esterification is coming in from, right? Fischer esterification is starting off with a carboxylic acid and producing an ester. And all it is just dropping in this nucleophile here, right? This protonated nucleophile here, and an acid. Transesterification is just an ester producing an ester, right? We can, starting with the ester, we can produce an amide. We can produce an amide. So we can have this occurring. What do you think we would have to drop in to create the amide?
From the carboxylic acid?
Oh, from the
Yes.
make this a little bit better. Go ahead. Just go ahead and take your time and think about it.
Like NH2?
Okay, but it would have to be protonated, right? So it'll be NH3, right?
NH2, okay.
But that would make sense, right? Most of them are going to be, well, they are going to be protonated, right? So we would have an H3. And since these guys are not all that reactive, right? So when we're looking at this side, these guys are not all that reactive. So you're going to be seeing them with some kind of catalyst, acid or base, and heat.
Okay.
Especially down here, the nitrile. You're going to be seeing heat. Because you're going to force the reaction to occur because these guys are not all that reactive, and in order to make them more reactive, we use a catalyst, an acid as a catalyst, or we add heat to speed up the reaction.
Okay.
And we're not going to be producing a nitrile. Let's see here. And the only reaction that this one can really undergo is just hydrolysis back to the carboxylic acid. Right?
Okay.
So it's not really going to be producing this guy here. Right? It's going to be going here. Okay. What if we wanted to form an aldehyde? You got SOCl, okay, you got PCl3 here. You could also use PCl5, but since you have PCl3, you can do this. Now, what if we want to create let's say we wanted to produce an aldehyde. Or let's say we want to produce an amine.
From carboxylic acid?
From some of these guys here, some kind of an amine. And let's see, what was the other one? Amine. That's amine. Carboxylic acid. Takes that away. Okay. So there's a way we can generate an aldehyde or an amine. Alright, so if we start off with the carboxylic acid here, there's what we can get here. Alright.
Water.
It's not really gonna be undergoing the oh yeah, it will be a substitution reaction. Yeah, it will be a substitution reaction. But it's gonna be a reduction reaction. Reduction. This is it. Okay, so but from here, from the carboxylic acid, we can get to the aldehyde, or from here, we can get here. Right. Now, starting with this guy here, the amide, we can get here. Right. Or starting with the nitrile, we can get here. Alright, all these guys are going to be reduction reactions. I just want to see if you have it here. Okay, so ester. Oh, and also this one here. But this one will produce an alcohol. Alright, let's see how comprehensive we can make this. So you can see here, right? Amide going to an amine, right? But I don't see the what did he use? What reagent did your professor use here?
I don't remember. This was the sub.
Okay, so it's not really here, right? Is trypsin?
Yeah.
Okay, cool. Okay, so but you can see nitrile. Well, actually, it's just hydrolysis. Okay, cool. Okay, so it turns out that if we use H2 Lindler, let me make sure this is correct. Alright, so if we use Lindler's catalyst, we can go from the acid chloride to the aldehyde.
Okay.
And also if we use lithium tributyltoxide, aluminum hydride. I'll draw out the structure for you so you can see how it looks like. So if we use any of these reagents, we can get to the aldehyde. So it looks something like that. This is the lithium aluminum tributyltoxide. I'm not sure how it's exactly abbreviated. Probably something like that. Alright, you might see something like this. So just know that both of these guys one or this one can lead you to the aldehyde. Right? Now let's see, I think there is one with the carboxylic acid. That it might be wrong. Okay, there might not be one with the carboxylic acid. Okay. There isn't one with the carboxylic acid. I was wrong about this. I thought Diabol would have done this though. Yeah, that's right. You have to leave by one, right? Okay.